This is 7172. 7.1, 7.2. I'm going to try to get through it all today, but this one does take, this is probably the longest lecture of the last ones. In fact, I guarantee you this is the longest one of the last ones. So we'll do our best. All right. So do you guys remember systems of equations? It's when you have two equations with an x and a y. We actually saw systems of equations problems in Unit 1 when we did those percent problems, those mixture problems that you guys love so much. Okay? All right. So we have to solve for an x and y. A solution to a system is a point that when you plug it into the equations makes it true. That is a solution for both equations. So it's like plug in a point and it has to work for both. So if you're ever asked, is this a solution to the equation? You plug it into the equation and you see if it's true. All right, I don't think we do that. So if I ask, is -3, -5 a solution to the system? Yeah, it occurs on both lines. It is a solution for both. Not going to spend a lot of time on this because I want to go to this slide. All right. I'm going to give you some key terms that aren't up here right now that you're going to want to know. When I am solving these systems, I can have one solution. If there's one solution, that means those two lines intersect. Intersect once, right? So that will have one solution. There is one point that they both share that makes it true. Okay? If there's no solution, it means they are parallel because these two lines do not intersect. If they do not intersect, there is not a solution. And if there are infinite many solutions, it means they are, I don't know how to draw this. They are the same line. It means when you graph them, they just graphed on top of each other. Okay? So those are the three options we're going to see in this unit, in this section. Okay? We can have one solution, no solutions, all the solutions. Okay? There we go. We are 5 out of 20 slides down. It's going to get kind of wild here. Today, my goal is to show you guys 3 different ways to solve these equations. So back in the day, you might have spent a day on each of these. We're going to do them all in one. That was loud. We could graph them, eliminate, and substitute. Okay? Now, I'm going to say this. I'm going to show you all of them. And then I'm going to tell you that I usually just pick one way and get really good at it because it'll work every time. Okay? But the first one, so let's look at how would we solve this graphing. All right? I'm going to show you 2 ways to graph it too. Way number 1, you guys have your TI-84 calculators, right? Make sure you have your calculator on you today. This unit is extremely calculator heavy. Get to know, love your calculator, become good friends with it. Tuck it under your pillow at night so you can learn more about it. Now on that calculator, can you plug in an equation with x and y right away? Like when I hit that y equals button, do I have a way to plug in a y and x on the same side? No. Nope. So what am I going to have to do first? To graph these, you need to get y by itself. Once y is by itself, can you graph them? Yeah. Yep. Will this work for any system of equations you ever have? Yes. This is, again, all these methods work for all of them. Okay? At the end, I'm going to teach you guys like when to use elimination, when to use like when's it easier to use one or the other. Okay? Because there are ways. So, on this piece, how do I get y by itself? Subtract the 2x over. So I get negative y equals negative 2x plus 5. And then I can divide by negative 1. I get y equals 2x minus 5, right? Any questions what I did there? Getting y by itself. Because my calculator can't handle not y by itself. So that's one equation. Gross fractions. Actually, gross fractions. All right, I'll subtract the 3x over. And I get, what, negative 4y equals negative 3x plus 10. It's always the same number of steps. There's always subtracting, divide. You do the same thing every time. Divide everything by negative 4. So this equation would become y equals positive 3 over 4x minus, what's 10 divided by 4? I'm going to make this a decimal to make it easier plugging my calculator. 2.5. Right? And if you really want to, could I have changed 3/4 into 0.75? Yeah, for some people it's easier to plug in decimals to a calculator, right? Because then you don't have to worry about your parentheses. So I'm going to show you guys this one time, and I'm going to show you an even quicker way to graph it. But it doesn't always show up. So I have two equations, right? I'm going to grab out my handy dandy calculator. No, stop it. Stop. Bad. Easy. Easy. There it is. And go ahead and graph these two equations. Let's graph them. So hit your y equals button. And we're going to do 2x minus 5 and 0.75x minus 2.5, right? So get those plugged in. Hit the graph button, and they should intersect at some point on your graph. If you're having window problems, call wall side. No. Hit zoom. If you ever get where you don't see a picture, hit the zoom button and go to Z standard because someone just zoomed you in goofily. So again, hit zoom, Z standard, and that will kind of put you back into a 10 by 10 window. Do these lines cross? All right. How do I know the exact point they cross? If you go and you hit, you guys see at the top there's a second calculate button, second trace. Second trace. Hit second calculate, and you guys see there is number 5 says intersect. The intersect will find you the intersection. So I'm going to hit enter. First curve, enter. Second curve, enter. Guess. The guess is for this. If there's multiple places they touch, you put the guess near the one you want to find. How many places do these ones touch? Once. So we don't really need a guess. We just hit enter. So I got the point 2, negative 1. All right? Let me know if you're having calc problems. I can come help you. All right. So here, if you want to jot down like a cliff notes for graphing, because I know you guys like to use your graphs as kind of like, or your notes have kind of step by step. If you're solving by graphing, your first step, you need to have y by itself, right? Second step, graph on the calculator, plug them in. Third step, second calculate, intersect, number 5. And then you're going to, if you really want to do it, remember you're going to have to hit enter 3 times, right? But if you follow those steps, will it work every time? It should. Get y by itself, graph it, second calculate, intersect, hit enter 3 times. Okay? So when you're using that TI-84, that's gonna do it for you. No. All right, so we did that one. All right. Oh, no, not this one. All right, let's do this one. All right, to solve by elimination, align the terms, force opposite coefficients, add to eliminate, solve for remaining variable, solve for eliminate variable. Goal is to eliminate one. All right, I'm going to tell you this. For elimination, I do not use elimination unless my coefficients match up. You guys know what I mean by that? So like, or they're easy to match up. I would not use elimination for example 2. Because if I were to use elimination, what I would have to do is multiply this one by -2 and this one by 5, and then combine them. And it just feels like a lot of work. I would actually probably graph these. Okay? Now, with that being said, I will show you what I'm going to do instead is I'm going to show you elimination on example 3. The reason why I'm going to show you an example 3 and why elimination works better for this one is because my goal is to add these 2 equations together and get rid of a variable, right? So right now, if I add these 2 equations together, I get 5x and -2y and 4. Am I getting rid of any letters? No. Is there a way I can get rid of a letter by multiplying one of the equations by something? This is a 1y, right? What can I multiply that by to get something that would eliminate that? 3. But now what do I have to times by 3? The whole thing, right? It's a balanced equation. So one like this, would I use elimination? Yeah, you could. I would still honestly probably use substitution. I'll show you that one next one. But some people like elimination. If you liked it when you did it, like in Algebra 2 back in high school, then yeah, use a lot of elimination. I just don't know. For me, I just don't care for it. So 3 times 2 is 6x. 3 times 1 is 3y. 3 times 8 is 24. I'm just going to move that equation over. You guys might have room in your notes to align this. I just don't. Now I have an equation like this. I have 2 equations. If I add these equations to each other, will I get rid of a variable? Yeah. So now when I add these 2 equations together, I get a 9x. What happens to these y's? They go away like my hopes and dreams. All right, equals 20. All right. Oh, does this really? Oh, fractions. So much fun. All right, so can we solve the equation 9x equals 20? Divide by 9, and x equals 20 over 9. All right. If you are a decimal person, that'd be what, 2.2 repeating? Again, that, puberty. So, now that I know what x is, what do I do with that x? I'm going to take it and plug it into one of the equations and solve for the other, right? So I'm going to do 2 times 2.2 repeating plus y equals 8, right? I'm avoiding the fractions. I could do this with fractions. It's not too bad. So it says 4.44444 plus y equals 8. Is that something we can solve? Yeah, subtract the 4.4. and I get y equals, I do this, 3.6 repeating, right? Or 3.67, right? If you are rounding to the nearest decimal point. So x would be 2.2, and y would be 3.67. Hey, let me show you guys how you can check yourself with graphing. What's up? Oh, is it 3.5 repeating? Thank you. This is why I'm stuck in this place. Oh, because 4, 5 is 9. Math is tough. I'm sorry, it's 3.56. Yeah, you have to do 4.44444 because it was repeating. All right. So if you're doing your homework on a computer, let me show you a neat way you can do this. Let's check it. Let's make sure we did it right. So I don't know if you guys have heard of this. There's something called Desmos. Not on the test. There's just no, I'll be honest, there's no way I can police it. Does that make sense?
I thought you can see our screens.
All right. If I graph these two equations on Desmos, do I have to solve for y by itself? You don't. Is that true if you're taking the SAT? Yeah, you don't have to solve for y by itself. You can just plug in the two systems, and it'll automatically give you the intersection. Uh-oh, what did I do wrong? 3.1. Oh, I did the first division wrong. That's fine. No, that's not fine. It's -4. Thank you. I was gonna say I'm infallible. Oh, there we go. 2.2 repeating 3.56. All right, but again, garbage in, garbage out on tech, right? Now, for this section, if you're doing your homework, what's a good way to check yourself then for all these problems? Plug in Desmos. Now, the reason why I need to make sure that you know how to do without Desmos is because when we do 3 variables, Desmos does not do 3 variables. You have to use substitution to do it. Yep. You can't graph with 3 variables. No, it'll say using any method. It'll say using any method. Actually, so when we get to 3, all right, this is my favorite method to solve 2. This is actually the one that is as quick as using tech, and it's my favorite way to do it because it makes sense in my pea-sized brain, obviously. I like how aggressive these slides are. It's like force the variable to be in one expression, and then substitute and solve for the eliminated variable. All right. It is aggressive. I'm sorry. All right, so let's do this. All right. What's our first step? We have to force that variable. Get by yourself. All right. Is that variable by itself? I'm sorry, everyone take a deep breath. It's okay. I'm fine. I'm okay. All right. This is a good spot to use substitution because do we have a variable by itself? Yeah. So my advice to you, if you ever have a variable that's been forced by itself, use substitution. Use substitution because we can go right to step 2. Since y is by itself, anywhere I see a y on this equation, I can plug in what it's equal to. Get to one variable. So I'm going to do 2x minus 2 times -x plus 8 equals 6. You guys see where I'm getting that from? Because I know what y equals. They're equal things. I can substitute one in for the other wherever I want. Because I forced it to be by itself. All right. So now that I forced that in for y, this is just algebra, right? You know what I mean? That's why I like substitution. There's nothing different from this and what we've done all year. Distribute the -2, right? I get 4x minus 16 equals 6. Is this really another fraction? Killing me, Smalls. 4x equals 22, and x would be 5.5. Do you get, so if you ever have x by itself or y by itself, what's going to be your best way to do this problem? Substitution. Substitution is by far going to be your quickest way to do it. Like, that's our next one. I'll go over that for our next example. All right, so once I know what x is, what do I do with that? Plug it in. And you solve for that eliminated variable. Yeah, you do. Where's that 5.5 coming from? I found it. I got 2.5. So what's my answer? A few people did miss this on the test. Not many, though. Overall, really good job. X and Y intercept, is it the answer a number or is it a point? It's a point. So what's the answer to a system? Is it numbers or is it a point? It's a point. The point is 5.5, 2.5. Could I graph both those in Desmos and check it and make sure I did it right? Yeah. I could. My heart rate got really high there for a little bit. I wasn't. All right, let's do a substitution. Hey guys, this is going to be a very unique one. This is an important one to go over. It says, oh, let's choose. What's going to be my easiest way to solve this system? Substitution, right? I have a variable by itself already. So I'm going to take this and plug in for x, right? So I'm going to do 2 times 3y plus 2 minus 6y equals 4. Any questions what I did there? I'm just substituting. So I get 6y plus 4 minus 6y equals 4. Guys, what's 6y minus 6y? So I'm left with 4 equals 4. My variables went away. So now if my variables go away, I can't solve for it, right? So it means I either have all the solutions or no solutions. Now here's the question. Is that a true statement? Does 4 equal 4? Yes. If this is true, then we have infinite solutions. Because it means no matter what number I plug in for x, it works on both equations. Okay? If that is not true, it means it's never true no matter what I plug in. If it's not true, it means it's never true for any equation, right? All right, so here we go. It's very frustrating on occasion to have to answer questions you just answer. All right, word problem time. We've done these word problems before. You actually do have examples of these from previously. But now we have better tools at how to solve these, correct? We're going to be better at solving these. We might not get to we'll try. We're going to do our best. All right, we're going to mix together some acid. We're going to mix 14% and 45%, and we want 22%. 4% problems, we're always going to have two equations. Do you remember we taught you're going to have one that adds up to the total and one that we have all the percents. So the first question I'm going to ask is, how many total milliliters do we want to make based on this story? What's my total? 210. So 210 is equal to mixture A. Well, actually, you guys want, let's do X and Y now, right? X plus Y is 210, right? When I combine my two fluids, I need a total of 210 milliliters. Now, what's my percent I want at the end of the day? 22. Now, what do I do with that 22? So it's 0.22 times my 210, right? Because that will give me the concentration of it. Okay? I'm using my total times the percent I want. So my percent of X we'll say is 14. And my percent of Y is 0.45. So those are my two equations. Again, does this kind of look familiar? You might not have liked it or know how to do it first time. That's okay. But we did these. The total equation in the homework, do you remember asking you what's your total equation, what's your percent equation? Same question is going to come up. What's your total equation, what's your percent equation? Now, I was just thinking, this is 46.2. If you want to make your life a little bit easier, right? You can multiply it out. I'm just showing you why it's 46.2. So, could I solve this by graphing, by getting Y by itself? Yeah. The way I'm going to do it is substitution. And the reason why I'm going to use substitution is this. Is it going to be really easy to get one of these variables by itself? Yep. So let's do that. Let's do that. Which variable do you want to get by itself? Y? Wait, what I do it? How about I do it the way I did in my notes? I got Y by itself. So can I change this to 210 minus X equals Y? Right? Subtract the X over. Yar nar. Can I do that? Thank you. All right. Now that I have Y by itself, that I forced it to be by itself, I can plug this in for Y, right? And solve. So I have 46.2 equals 0.14x plus 0.45 times 210 minus x. Okay. And now that looks messy, but it's just distribute and solve. Distribute and solve. So distribute and solve. Pew, pew. 46.2 equals 0.14x plus, was I good? Yeah, I was. 94.5 minus 0.45x. There we go. So again, I know I say this all the time, but this is a lot of work, right? But each step, break it down. Do it step by step. Can I come up with a total equation? Can I come up with a percent? Step by step. Can I subtract the x over? Yipers. I skipped some steps. That's okay. I subtracted the 94.5 over, right? And I combined my like terms. This is going to get messy. But life's messy, and that's okay. Negative 48.3 equals negative 0.31x. Divide by it. Divide by it. So I got x is 155.81 milliliters, if you want to be real cool. I hope so. I used A and B on my sheet because I'm a goofy gusser. All right. How am I going to find y then? Yeah, just do that equation. 210 minus 155.81 is 54.19. Perfect. I can wait 3 seconds. This 14? I combined these like terms. I did this plus that was the 0.31, negative 0.31. What's up? You can. Okay, so I had a decent question from a random audience member. Could you use elimination? Yeah, you could have multiplied the whole top by like negative 0.14. Oh, actually, we do have time. I'm going to show you. I'll start the next one with elimination and show you how that looks different. Because some people, Dr. Webster does these with elimination. So I'll show you the first step, the step, and the first step of the next one, and then we're actually in a good spot. All right, you're mixing candy together. One's strawberry and one's blueberry, and the other's strawberry and the other's blueberry. You need to make 30 pounds of candy with 60% strawberry and 40% blueberry. All right. Whew. All right, how are we gonna do this beast? How many total pounds are we gonna make? 30, right? So what's my first equation? X plus y equals 30. If you can at least get that, that'll give you 1 out of 3 points on the test for this one. It's true. That's the total equation. Now, here's the question for you. This one's tricky. It gives me strawberry and blueberry and strawberry and blueberry and strawberry and blueberry. That's 6 pieces of information. I only want 3. Here's my thing. If I know the percent strawberry, will I know the percent blueberry? So can I just ignore blueberry till the end? As long as I know strawberry, it's going to be the same. So I'm going to ignore blueberry. This is a wild thing that I'm saying right now. I'm just going to ignore it. I'm going to ignore it like never mind. I'm going to ignore it like I got ignored in middle school dances. All right. So, what are my percentages of strawberry? 0.72x plus 0.5y equals 0.6 times 30, right? Do you guys agree with that statement? Oh, we're doing good. So now, 0.6 times 30 is 1 point, not 1.8, 18, right? 18. All right. So a person here said, well, if we tried to use elimination, is that tough? No, actually elimination is very straightforward for these. What do you want to get rid of, the 0.5 or the 0.7? It doesn't matter. I would do the 0.5. So I times this whole thing by negative 0.5, right? That's half. And so I get negative 0.5x minus 0.5y equals negative 15, right? So those are my 2 equations, right? That's nothing. So now when I add those 2 equations, what happens? Those are going to cancel, and you get 0.22x equals 3. So honestly, elimination might be less steps, right? You guys see how that's a little bit less messy? Will elimination always work for these? Yeah. Because honestly, you divide by 0.22, and I got x equals 13.64 pounds. And that also means then y would be 16.36 because they have to add up to 30. So honestly, with these, elimination might be quicker. So I multiplied this by negative 0.5 at the top to match, but be opposite of that one. Yeah.